Okay, testing, make sure I've got the entire board. Okay, we have a table, and we want to graph the function defined by this table. So we go ahead and sketch. An x-axis and a y-axis. We note that the x values go from -4 to 4, so let's go ahead and put 4 out here, and then at equal distance on the other side of the axis, we hope, we'll put our -4. And then we divide this interval in half to get position of 2. We divide that in half to get 1. Divide this interval in half, we get 3. Divide this interval in half, we get 1/2. And divide this interval in half, we get 1/4. And we see we need 1/4. Okay, so here's 1/4. We do the same thing on the other side. It looks like my 4 is a little too close, but we'll just live with that. In a hand sketch graph, you never have full precision. And up here, this will be where y equals 2, and we go down as far as -2, so we'll put -2 about here, so that -1 will be here, 1 will be here, -1/2 about here, and 1/2 about here. Again, I don't have the scale perfect, but we understand what these marks mean. I don't have to label them everywhere, but I'll label 1 here, 2 here, and so forth. Okay, so we're going to label, we're going to locate the point -4, -1/2, and I labeled my 2 and my 1 below the axis, and that's going to get in my way when I try to locate this point, as you'll see. So here's 2, here's 1. Okay, so -4 is here, the line through, vertical line through -4. All points where x equals -4 lie in this vertical line. A horizontal line through the y equals -1/2, and they meet at this point, so right here's a point on our graph. And then -1, -1, we can draw the projection lines. And -1/4, -1/2. -1/4, -2. Now this is not, incidentally, one of our basic functions. It's a composite of a couple of our basic functions. We'll deal with that a little bit later. And actually it's been modified from that. So the expression for this function is actually a little bit complicated. So we're not worried about that. We just have this information. This is all we need to know to make this graph. Okay, so then we have the point -1/4, 2, the point 1, 1, and the point 4, 1/2. Well, that's a graph of the table. Okay, so we would call this the point graph corresponding to the table. Now we can extend that point graph. Okay? We can certainly say, well, the point graph ought to be some kind of a smooth curve that goes through these 3 points. So I'm going to kind of draw a curve here with a kind of a, okay? Didn't hit it exactly right, but you get the idea. And I can draw a smooth curve from here over to this point, passing through the point right here. And that curve might look something like this. Now that's just a guess as to where the curve would be. We don't know any more about the function, so it's dangerous to extend the function beyond this point is the curve beyond this point. We don't know if that curve approaches a horizontal asymptote above the x-axis, or it somehow manages to approach the x-axis. Similarly here, we don't know what happens above here. One thing that we're fairly sure of, the curve doesn't connect this point to this point. Okay, these points are not connected. So this is a big deal. No curve connects the points -1/4, -2, and 1/4 2. Why not? Because the function is undefined when x equals 0. If I sketch some kind of a curve, maybe it just turns around here and goes straight up here or whatever, or maybe it goes up here and curves around here, that curve is going to go through the y-axis. The curve can't go through the y-axis, because if it does, at whatever point the curve intersects the y-axis, that's got to be the value when x equals 0, and there is no value when x equals 0. So no curve connects this point to this point. Since any such curve would pass through the y-axis and give the function a value for x equals 0. Okay, so we can't do that. So the best we can do with the given information without extrapolating to something we don't know or can't be sure of is we can be sure that we go through these 3 points. If we know that we have a smooth curve, then we can make a pretty good guess what the function does here. From this point to this point, no further. I can put a closed dot here and a closed dot here, and that's it. Anything else is guesswork. Now, there is a bit of guesswork in drawing the curve, but I've drawn a pretty reasonable curve, and it's a reasonable assumption that that curve is at least in the ballpark of what this function should do. Now, it could be wrong. You know, this function could come down through here and go down here and then come back up through here. Could do a lot of things. So we're making a best guess, the simplest possible guess for the curve is that it looks something like this. Now, we could speculate. We could say, well, it sure looks like this thing's going to approach the y-axis as an asymptote here, and approach the y-asymptote as the y-axis as an asymptote. We can usually talk here. It's a little less certain that it's going to approach the x-axis as an asymptote, so we have a lot of guesswork there. Maybe the asymptote's above the x-axis. Maybe it doesn't even have an asymptote. Maybe it turns around at some point, goes up. We don't know that. Okay, so we apply this to graphing certain basic functions. And the main thing is we have to understand that if there is a point, an x value where the function is undefined, we don't try to connect what happens on one side with what happens on the other side of that asymptote. Okay, well, this is an important point. It's an important thing to understand about undefined functions that are undefined at certain points.